All right, so next up we're taking a look at how we can use our calculator for trigonometry. The first thing you really want to be careful with trigonometry is making sure your mode is in the correct location, correct value. So see how it says right here, radian? That means I'm in radians mode. And this problem is you can see it has the little degree symbol. We want to be in degrees mode. So you just press mode. You get the screen like this, and we want to scroll to where you see radian highlighted. And we scroll for degree, and we make sure that's highlighted. Whether your screen has all this stuff or a little bit less, like if you have the TI-83, your screen will probably not have as much information here, but that's okay. You still have the same spot. It's still mode. Make sure degree is highlighted rather than radian, and then we just hit second mode to quit out. So cosine, sine, and tangent are your three main functions. Those are these three buttons right here. So if I want to do cosine of 35.7, we just press cosine, and then 35.7. You don't need to close out the parentheses for this problem because that's all we're doing, but it's good practice. So always close off your parentheses from your trig function. And we hit enter, and there's our decimal value. Cosine of 35.7 is exactly 0.8120, and then a bunch of other numbers depending on how far you want to round. All right, so next up, now this is one sine of pi over 9. And pi over 9 is in radians mode, so we're going to go back to our mode button. We're going to select that and move it back over to radians. Make sure radian is highlighted, second quit out. So now sine is our button right here, so there's our sine. And then pi is, you can see they're in blue with this symbol right there. So blue means our seconds. We're hitting seconds, exponent button, that's what it is, the caret symbol there. Over 9, close our parentheses, and we hit enter. And there's sine of pi over 9. Like with the cosine from the previous example, for the most part, these are not exact special angles from the unit circle. 30, 45, and 60s, based off your special right triangles, things like that. These answers are not going to be nice. They're going to be decimals. And a lot of times it's not going to be very intuitive. So you do need to trust that you're typing in correctly, because knowing that, 0.34, that makes sense for sine pi over 9. Maybe if you see it a lot, but otherwise not so much at first glance. Now, and this trig we were doing for degrees and radians, we obviously did an example of cosine, example of sine. You can do that really for all three functions. This one is tangent, but they want us to solve for x, the angle. So if we have tangent x equals 3.9, we have to use our inverse. So the inverse you can see right there is at tan negative 1. So we're in second tangent of that 3.9. That gives us the angle. So this would be 75.6186 degrees. Tangent of that will get you your 3.9. So anytime you're trying to solve for an angle, it's always an inverse function, whether it's sine, cosine, or tangent, but it's always the inverse, that negative 1 symbol right there. So next up here is a little more interesting of a question. This is based off our law of sines. So if you haven't quite gotten to law of sines yet, so you don't necessarily need to watch this, but for those of you coming in based off law of sines, so here's where we have our ratio, our proportion for law of sines, where sine 50 over 40, sine 75 over b, we're cross multiplying, that's why we have b sine 50 equals 4 sine 75, and b is the unknown. And again, while it may not necessarily look like it, sine 50 is just a decimal, kind of like what we were just doing before. So we have to divide the expression over to get b by itself. So typing this into the calculator, there's two ways we can do this. We can do it as 4 and then sine 75, making sure we close off our parentheses and press our buttons correctly before we do our divided by sine 50. Closing off the parentheses, and we hit enter. So this value of b would be 5.0437. Now, with the newer, and this is really your only option with the 83s, with the newer 84s, you can hit alpha y equals, and this gives you now a fraction option. That first thing right there is our fraction. We select that, and now we can fill it as the fraction. So 4 sine 75, close the parentheses. I did it again. 75, there we go. Over our sine 50. This is very useful, as we saw with the, and if you haven't watched it yet, you should, the log video showing how we can type in with the logarithm calculations where it becomes a more complicated expression. Top and bottom have a lot going on. It's better off doing the fraction button if you can rather than doing the parentheses option. In each case, you see you're getting the same exact answer. All right, so that's one application of law of sines. We'll take a look at the next application on the next one. So here's our next application of law of sines. Here, we're still cross-multiplying, and we're still dividing to isolate the variable, but the variable is part of a trig function because it's sine A over 6.5 sine 34 over 5.1. So it's 5.1 sine A equals 6.5 sine 34. So again, divided by the 5.1, A is not truly by itself. But as we saw a couple of examples ago, anytime I'm trying to get the angle by itself and it's part of it, it's connected to a trig function, we do our inverse. So we're doing the sine inverse of this value right here. So we're hitting second sine. And again, I'm going to use my alpha y equals to create my fraction option here. So the 6.5 sine 34, and then over our 5.1, right arrow out of there. We have to right arrow because otherwise it was on the bottom. Close our parentheses. Now we can enter. And there's our angle. Now again, if you have the 83 or you have an older 84 that doesn't have the alpha y equals fraction option, when we do our second sine inverse, it gives us a set of parentheses. We're still going to create our own for the numerator, 6.5 sine. Notice it gives us another set right there for the 34. We have to close it once for the closing off sine 34, and a second time for closing off the 6.5 sine of 34. And then it's divided by 5.1. And then we close off one last time to close off the entire inverse. And we can see it's the exact same answer. So obviously the alpha y equals is much more convenient, so we're using that option wherever possible if you have the newer 84s, which I'm sure a majority of you do have. But if you still have an older 83, it still does all of this stuff. You just have to be a little more careful with how you're typing. All right, so our last example here is using the law of cosine. So we can see we have cosine A equals the 18 squared plus 17 squared minus 25 squared over 2 times 18 times 17. A is nicely, we have to do our cosine inverse. So again, the ideal method, that we're hitting seconds cosine, is your alpha y equals, so we can do as a fraction and just put it there in one step like that. 18 squared plus our 17 squared minus our 25 squared all over our 2 times 18 times 17. Have to right arrow out of there to be able to close out the parentheses for the inverse. Then we get 91.1235 degrees. If you don't have the alpha y equals option, you got to be much more careful because there's so much going on in the numerator. You're going to have to put parentheses, and then we can start typing our numerator. 18 squared plus 17 squared, 17 not 7, minus 25 squared. Closing the parentheses is just the numerator closed, dividing by new parentheses now for the denominator, 2 times 18 times 17. Closing the parentheses for the denominator, closing for the entire inverse, and there's our same answer. All right, so just be careful with how you're typing with the parentheses, especially because none of these answers are intuitive. At first glance, looking at this, there's no way for me to know that this was going to be 91 degrees. Speculation could have been like, based on some knowledge I have of the sides there, being a bigger answer, sure, because 25 is bigger than the 18 and 17, so this should be the biggest angle in the triangle. Telling me, because I got 18, 17, and 25, it's probably got to be definitely bigger than, 60 degrees, which would be all of them the same. Where exactly is it? No clue. Same thing with all the other ones. None of us would have a true intuitive sense for this. So you have to be very careful with how you type into the calculator. If you mistype things, you're going to run into some issues.